So 27n squared. We're going to do what we just did with the number. If you don't know what the primes are, we do the factor tree. So that would be 3 times 9 and 3 times 3. So in our radical, we have 3, 3, 3. Now, you have to think back. I don't care how you do this, but I'm going to give you a tip that will hopefully save you some time when it comes to variables. N squared is really n times n. If you want to write out n times n, you can do that. But when you get to n to the 16th, for instance, you probably don't want to write out 16 n's, right? So the time saver is when you have a variable, if you have an even exponent, that represents a pair or pairs, right? If the exponent is even, when you pull it out, you're going to take half of whatever that exponent is. Because right now I have 2 n's, yes? So they'll come out as 1, because it's half of the pair. So I'm going to keep the exponent on that. So my pairs are those. So the 3 is going to stay in, that has no partner. From this pair, a 3 is going to come out. And half of the n squared is just n, right? So that would be simplified. All right, let's look at another one. In this one, we have something out front. We also have an odd number of a's. You could list out 7 a's, but if you don't want to, I'm going to tell you again what the shortcut is. So 60, we need the primes for 60. So it would be 2 times 30. 30 is 2 times 15. 15 is 3 times 5, and those are both prime. So in our radical, we have 2 times 2 times 3 times 5. Now the a's. If the exponent is even, we can just take half of that. But when we have odd, we're going to take 1 off of there. This is Mrs. Rush. Hi, good. She's not here. Nope. You're welcome. Yep. Bye. Okay. So if we have 7, we're going to make this a times a to the 6th. Would you agree that that's still 7 a's? We just took 1 and separated it. Yes? You guys all right with that? Well, I'm going to show you, because remember, we said the even exponents represent pairs. So when I'm looking for those pairs, there's a pair of 2's, and this even exponent on a represents pairs as well, right? If there are 6 of them, how many pairs are there? 3. So the 3, the 5, and the a, those are the ones that have no partners. Those would stay in, and you'd multiply the 3 and the 5 back together, so this inside would be 15a. The 2 is going to come out, and half of those a's. So we need to decide how that works with negative a. The negative is going to stay at the very beginning, right? So move that way out front. So we keep the negative because you don't put negatives in the middle of a product, right? You put them in the middle of a product, it looks like subtraction. It's not subtraction. So the 2's come out as what? Just a 2. Half of those 6's would come out as a to the 3rd, but what happens when I already have 1 out there? A to the 4th, yes? A to the 3rd plus the 1 that was already there. So that would be a to the 4th. And that is simplified. Because a to the 6th is 1, 2, 3, 4, 5, 6, right? We're taking out 1a here, 1a there, 1a there, which is half of that. So 3 a's are coming out, a to the 3rd, but you already have one out front. It's not the base is negative, not the exponent. The exponent on this is 1. So if I take out, remember, so this would be times a to the 3rd. A negative base is a negative base. That's like putting -1 times a. It's still a negative in front. Okay, so we're going to do one more off of your homework. This is the last one on the homework, which is negative square root of 48b to the 4th. You can take it off the homework, but you should make sure you have it in your notes. Okay. I want you guys actually to try this one.